Hi, today we are going to be looking closer at similar polygons. So first, determine whether the polygons are similar. And a reminder, this means that angles that are corresponding are going to be congruent and the corresponding sides are going to be proportional. So when I look at my first diagram, I have nothing given to me about angles. So that's not what I'm going to check. That's not what I'm going to show because I can't show anything with angles. So I have to say whether or not the corresponding sides are proportional. This is going to give us two different things that we have to figure out. One, which sides are corresponding to each other, and two, are they proportional? We can't just look at sides that are written next to each other in the same spots because we don't know the order in which they are corresponding. We have to look at the numbers because I don't have a similarity statement. When I look at the first triangle, let's just start with the smallest side. 8 is the smallest number. I look to the other triangle and I find the smallest side. DE. The smallest side has to correspond to the smallest side. I can't have the largest side and smallest side being in the same spot. So that's how I can figure out which sides are supposed to correspond to each other by the order of their sizes. So we have that BC is corresponding to DE, which is 8 over 28. 8 over 28 reduces down to 2 over 7. I have to see if the ratio of the remaining corresponding sides is that same number. If it has the same ratio, then they are proportional. So the next smallest side is 14, over here 49. So AB is corresponding to EF. 14 over 49, divide both by 7, that gives us 2 over 7. So far, so good. And that leaves us with our last one. 21 is the largest, which is AC, corresponding to DF. 21 over 73.5. And if you're wondering how am I getting these numbers, I'm just putting this into my calculator. 8 divided by 28, math frac. 14 divided by 49, math frac. 21 divided by 73.5, because this one might be the one that you can't do in your head. When I enter that into my calculator, I math frac it, and I get 2 over 7, which is good news. So we are going to say triangle. We look at corresponding order. So if I just pick the first one, ABC, I went from A to B to C. So I'm going purple, blue, green. I have to follow that same order over here. So to go from purple to blue to green, purple, blue, green, I'm saying triangle FED. Remember, how you name the first one doesn't matter, but you have to match it up corresponding to the second one. So I can say that triangle ABC is similar to triangle FED because all corresponding sides are proportional, which means they all reduce down to the same ratio. And in this case, so if we look at our sides, AB corresponds to FE. That is equal to BC and ED, and AC and FD. So all corresponding sides are going to be proportional to each other. Next one, given that your quadrilateral ABCD is similar to WXYZ, solve for x and then find the length of WZ. So the first thing I'm going to do, we are given very important information here. Because I was given the similarity statement, I know which sides are proportional and which angles are congruent. The first thing I'm going to check is to see, are my sides drawn in corresponding order? So ABCD, ABCD, WXYZ. Perfect. The letters match up here with the way the diagram is drawn. Why that makes it so easy is so that I can visually see that AB and WX match up. They're not out of order the way they were up here in the first one. And it just makes it easier when we look at the pieces that are corresponding to each other. DC, YZ, and AD is corresponding to WZ. I'm going to use the fact that they are proportional. So AB is corresponding to WX. The ratio of those two corresponding sides has to be equal to the ratio of all the other sides. Well, BC we don't know anything, XY we don't know anything, so we don't have to write that out. DC we don't know, YZ we don't know. But I do also know that AD is corresponding to WZ. So I can write AB, which is 18, corresponds to x plus 4, and 30 over 2x minus 1. So I just wrote a proportion using the ratio of two corresponding sides. Now we solve this proportion, which we know how to do. So it's 18 times 2x minus 1. Remember, anytime there's more than one number, we put parentheses around it, equals 30 times x plus 4. We distribute 18 times 2, 36x, 18 times negative 1, negative 18, 30x plus 120. We're moving that entire term over, so we subtract. 6x minus 18 equals 120. We add 18. That gives us 6x equals 138 divided by 6. And we find that x is going to be equal to 23. Now we have to determine the second part. Is it an enlargement or a reduction? And remember, this is based on the similarity statement. So I'm going from ABCD to WXYZ. So if I start here and I go to here, are my numbers getting bigger or smaller? So if x is 23, 23 plus 4 is 27. So I'm going from 18 to 27. I'm getting larger. Therefore, this is going to be an enlargement. Most of the time we can get there, and it's not an actual question that we were given, but on your quiz, your test, I'm going to ask you, what is the scale factor? So I know I'm getting larger, so I'm multiplying by a number that is greater than 1, but we compare those sides. So 18 times what scale factor is going to give us 27? So we divide by 18. 27 divided by 18 is going to give me a scale factor of 1.5. That's a clean decimal, so I can use that. If it was a weird decimal, I would leave it as a fraction, but we're good with 1.5. Okay, our last problem for today's video. This one can be tricky. Given the following three rectangles, which ones are similar? So we have to check all combinations. So we have to look, is 1 similar to 2? If it's similar, corresponding sides are going to have the same ratio. So I picked the smallest side and the smallest side, 6 over 5. The next two sides have to have that same ratio, 14 and 15. Those two cannot reduce, and they are not the same. So rectangle 1 is not similar to rectangle 2. Is 2 similar to 3? So we pick the smallest one and the smallest one. And we get 5 over 15, which is 1/3. Then we pick the largest one and the largest one. 15 over 35. That reduces down to 3 over 7. So that one is not similar. So now we have to check, is 1 similar to 3? We picked the smallest one of 6 and the smallest one of 15. Both of those are divisible by 3, giving us 2 over 5. And then we've got 14 and 35. 14 divided by 35. Those are both divisible by 7, giving us 2 over 5. So since 1 and 3 both have the same ratio of corresponding sides, I'm going to say that rectangle 1 is similar to rectangle 3. Explain how you know that. Basically, what did we do? What did we check for? We know that because their corresponding sides are proportional. And we showed that by showing that 6 over 15 reduces down to 2 over 5. And 14 over 35 also reduces down to 2 over 5. Then 2 questions to go along with this are, what are the scale factor and what is the similarity ratio? If you think back to the transformation unit, remember these two numbers are always going to be reciprocals of each other. So let's just look at the scale factor, find 2 corresponding sides. So we know that 6 and 15 correspond, the smallest one to the smallest one. So 6 times what scale factor is going to give us 15? We divide by 6, and we find that the scale factor is 5/2. So it's going to be getting larger. Now if I had written my statement 3 to 1, it would be getting smaller, so it would be 2 over 5. But because I wrote my statement 1 to 3, it's 6 becoming 15, so it's getting larger. So if the scale factor is 5 to 2, the ratio is 6 to 15, which is 2 to 5. And again, the scale factor and the similarity ratio, those are always going to be reciprocals of each other. This is a big question for your quiz and test. Lots of parts, meaning lots of points. All right, and then we are done.